like this. You can, if you want to, like R space 8000. Okay. Our starting address is what? Is 8000, right? Second address is 8001, 8002, 8003, 8004, 8005. Okay. So our starting, the first digit in the starting address is 2, right? Is right now is in it's in the address of 8002. Do you know why we have 8002 here, right? We load 8002 in the HL register, okay? And then we're loading the contents of the HL register to what? To A. What is the contents of the HL register right now? It's the A, right? So basically, we're not interested in this way because we have to work with binary numbers, right? So we're gonna change the 8 into binary. So we're calling the subroutine ASCII to binary, and then we're gonna convert this to binary, okay? Then we're going to increment the HL. What's gonna happen when we increment the HL? What is our address right now? It's the 8003, right? Because we started with 8002, when we increment it, we are now at 8003. We're loading the contents of HL, which is the address 8003. Go inside 8003, what do you find? You find a 0, right? Then when you load it in the A call ASCII to binary, you convert it to binary. Then you increment by 1. You're now in address 8003. You go to 8003. You go to 8004, that's right. And then you convert it to binary, and then you increment by 1, you go to 8005, ASCII to binary, and then this, then you go back. Now basically what they want to do, want to put the first 2 numbers into the D register, and the second two digits into the E register. We can't do that straight up like this. We have to first convert it to binary, put it into DE, put it into D, convert the contents of 8004, 8005, put it in the E register. So this is how we're gonna do it. Okay? Then we're loading what's inside 8002 to HL. Okay? And then we call combine. Combine, basically what does it do?
Combine 2 and 3 together, 4 and 5.
Exactly.
And you get your DE.
How basically the combination happens, you take the first number 2, okay? You shift it left 4 times. And then you add it to the second address so that you're gonna have 80 into one place. Then you put all of that into the D register. We're gonna come to it in detail, the subroutine. So now the combined number is stored into address 8003. For the second part, we're having the address 8004, right? So we're gonna load 8004 to HL, and then we're gonna call combine. Combine, what's gonna do is gonna pull what's inside 8004, 8004, convert it, and put it into the E register. Okay. So now we're going to put what's inside the 8003 to A, and then we load what's in A to D. So now the first combined part, which is the 2 digits, 80, their equivalents in binary, they're going to be into D. And here's it for the second part. Second 2 digits are going to A first, and then we're loading what's in A2 to E. Okay, now we're swapping. Why? Because we just need to make a copy. Okay, we're swapping what's in HL to DE and what's in DE to HL, because we're going to make an operation into the DE and then go back and use the HL again. Okay? So now we're loading what's into H to D, and then we're loading what's into L to E. Now, why we're doing this? Because after that we're going to call a message 3, which states the following. The address that you have chosen to run is whatever address you put. Okay. Then we're gonna call outstring, which is gonna print the message. Okay. Then what we do? We reverse the operation. Here we did load H to D and then load L to E. Now here we're doing the opposite because we need our registers back in position. So we load what's in D to H and what's in E to L. Okay. Now we load what's into H to C, and then call the register C to screen. C to screen, basically it prints what's inside the C registers, it takes it to the screen. So what's inside H right now? It's the first part. Because we loaded what's in D to H. Second part, we're loading what's into LTC, call C to screen. We're loading the second part, put it to screen. Okay? And then we're loading message 4. Message 4 is just a dot. So, and then call out string, then jump back again to main. When you jump back again to main, what happens? It asks you for another operation. Like it, okay, we jump to main, right? It's gonna go to main. 1 second, yeah. So it's gonna go to main and ask the user to type something. Because this is how the code is gonna go. After you finish the run, choose the address. It's gonna ask you, do you want to do something else? Do you want to run again, or do you want to modify, or do you want to examine? Okay. Now we're gonna go to modify. You see now, modify is basically the first part is kind of identical to run. This is why I told you, to understand the run, you can get anything basically. Right. So we're doing the same thing over and over. Let's say I chose to modify address 8500FF. Okay. Now I want to modify the locations from 8500 to 85FF. Okay. This is how it's gonna start. It's gonna be 8500 colon, and then it's gonna 1 2 3 4. Then this is going to be length of 16. Then it's gonna go 8510. Then it's gonna go all the way down to 85F0, and this is gonna be 1 2 3 4. Then this is the last address, which is an F. Okay, so this is why 850 then 1 2 3 4 5. So the last address is 85F. Yeah, it works. Okay. So now I chose to modify this address, for example. Let's see how the code is gonna do it. Okay. So we're loading. This is the first thing in 8002. Why? Because we chose our starting address in 8000. This is 1, and this is 1, and this is 2. So we're loading this to HL, then ASCII to binary. So basically, we are converting all of this to binary, then we combine it, and we put it, you know, and then swapping, same thing as we did in the run. Okay. Now here, okay. Basically, we're gonna load message 7 to the HL register, which states the following: the address I have chosen to modify is 8500. Okay. I mixed between modify and examine. Modify, we don't use this. This is for examine. Right? So, yeah. So let's take a step back. So basically, a modify, what does it do again? We'll go to a specific address, take the content of what's inside, and then change what's inside. Okay? So basically, this is how we do it. So, what is modify? Here's modify. Okay. So now here it tells us the address that you've chosen to modify is blah blah, call out string. Okay. Then we're returning back everything back in position, loading what's in D to H, what's in E to L. Then we're printing to screen the address we chose to modify. Okay. And then we're loading message 4, which is just a period. Then putting D to H and E to L. Here is most of the work starts. So we're now loading what's in H to C and what's in L to C, because both of them are going to go to screen. This is going to take care of this part, 8500. Okay? And then we want to put 3AH to B. What is a 3AH? 3AH is a colon. Okay? To the B register, we call out character. Why we call out character, not out string? Because this is just colon. Okay, so this is why we use an out character. Then we're exchanging what's in HL to DE, just to make a copy. And then here the user inputs whatever they want to be there. So now we went to that location, and then I want to change the contents of that location to 55, for example. I type 55. So call the in string. It asks the user to type something. Whatever the user has typed is going to be saved into the 8000 location. We put it onto the HL. We take the contents of the HL, which is the 55, for example, load it into A, convert it to binary, and then we load it back again. Then we increment by 1. Go to the second address. And then take the contents of what's inside, convert it, convert it to binary, and then we're going to combine the number, and then it's going to be saved in what? In 8001. Then we exchange DE with HL so that we can make a copy of the HL, and then the new modified code that the user wanted is now entered into the desired location, right? Then we increment HL and jump modify 2. What happens when we jump back to modify 2? It's going to ask the user for the second location if we want it to be changed. So it's going to jump to the next address. It shows you what's inside. You want to change it? Yes, I change it. It goes to the next address. And you can check exactly that what you've done was right or wrong by examine, or by modify and go to the same address. If you go modify to the same address, you should see the change value that you did. Alright. Now we'll go to the last part of the code, which is examine. Examine, what does it do? We go to a specific location, and we set a starting location, we start an ending location, and it shows you the contents of all those locations, from start to end, and then it stops. First part is identical to the run, exact thing that we did, okay? This is the new part here. What happens in here? Can I get an... Okay, I can use that paper. So, examine 8500 FF. This is a space, and this is a space. Okay? So this is, we said, we agreed that this is 8000, 1001, 2, 3, 4, 5, 6, 7, 8. This is why you see here address 8007. We're loading address 8007 to HL, okay? And then we're taking what's inside the HL, put it into A. What's inside the 8007, it's an F. We move it to A. And then we convert it to binary, then we increment HL. So HL right now, what's the address of HL? It's 8008.